All right, let's start with slide 10 again. We were talking last about the standard score, the z-score, and the t-score. Basically, the standard scores are used when a researcher wants to know about a certain score in the data set, certain raw score in the data set. So the standard scores are actually how many standard deviation is a particular raw score from the mean. So the only z-scores and t-scores are nearly the same thing. The z-score is basically the mean is fixed to 0, and then the length is set to 1. So basically how far it is, and then the t-score is the original mean and standard deviation are converted to 50 and 10 respectively. The main thing that you want to know about this is the fact that the z-score tells you how much standard deviation is the raw score from above or below the group mean. That is the most important. So if you have, let's say, a z-score of +2 indicates a person is focused 2 standard deviation from the group mean, and a -1.2 indicates that the person is 1.2 standard deviation below the mean. And that's the same thing for your t-scores. Is if I have t-scores, the mean is a 50, right? And standard deviation is a 10. So if I have a t-score of a 70, that means it is 2 standard deviation above the mean. If I have a score of 38, that means go down 10, that is 1 standard deviation, and then 2 more. 38 is 1.2 standard deviation below the group mean. So like we said, all of this works when it is a normal bell distribution, a normal bell-shaped curve. But what happens if it is not a bell-shaped curve? It is not normal. It throws off your standard deviation. On your page 29 and page 29 and 30 are the ones for you to look at. So if you have your outliers, or if you have scores so this is a negatively skewed distribution, which means that mode is the highest value and mean is the lowest value. So your extreme scores are basically towards your left. The skewness value is less than 0 for this. So let me give you an example and explain what do I mean by extreme scores. Suppose you take a test, a statistics test, and most students did very well, but there were very few students that did poorly. So their scores, the extreme scores, will write on the tail on the left hand side, which will make this to be a negatively skewed graph. In this case, the mean is lower because when we factor those extreme low scores with the high scores, they're going to pull down the mean of the class. But because most students have done well on the test, the mode is going to be the highest. You do have questions on your quiz related to this skewness, negative and positive skewness. So if we look at the positive skewness, we could talk about we make a group of students to go to the camp or something like that, and we have all the students that are like the ages and things like that. When we did, they were all around the same, and we had very few students who were like in older that went to the camp. So in this case, again, your mode is the lowest value because there were more students of younger age than they were of the older age. If I use the test example again, that means more students did poorly, but the mean was pulled towards the right because of the high scores of few students. So that is why this one is called right skewed and this one is called left skewed, which is negatively skewed. On page 30 of your book, it shows you a positive skewed and a negatively skewed graph. What you need to remember about is where are the extreme scores and which value assumes the highest position. Mode assumes the highest position in a negatively skewed one, and mean has the lowest position, while it is the opposite case when we are talking of positive skewed. The peak is not telling you it is the highest. Remember, this is your x-axis, so it is going from 0 to positive. So the mean is higher because it is further away from the origin, and mode is smaller. So do not confuse the peak with the highest. This is just a distribution that they're talking about. So that means this value, there were more of this values. Another thing that researchers report about is the kurtosis. The kurtosis is, even though we may have a normal distribution, sometimes the distribution would be overly peaked, which is a leptokurtic, or it could be very flat, which is a plateaukurtic. And if it is neither flat or neither overly peaked, it is called mesokurtic. So these are the things for you to remember. Leptokurtic is peaked, plateaukurtic is flat. Plat means flat, like lepto means leap somewhere. So that is where it comes with. So now we're going to switch gears a little bit, because we've been looking at the representation, data representations. But one of the first we also need to know is what are the different ways the researchers represent the visual representations of what we are reading. So here is an example. This is not from your book, but you do have simple frequency and group frequency in your book. So when you look at the simple frequency, it basically says this is your age category, which is your nominal data. And in this age category, we have 18 years is 213. 19 years is 302 frequency. So if you calculate the percentage, we take this frequency divided by the total and multiply by 100 will give you the percentage. So, and then this is just rounded off percentage. So look at this percentage and then look at the cumulative percentage. What is this change happening? Why does it say cumulative here? That means when we are talking about 19 years, it includes 18 years. So when we are talking about 20 years, it includes 19 and 20. So your frequency is all of this added up, divided by this, and then you get your percentage. So that is the difference between percentage and cumulative percentages. So when I'm looking at a simple frequency graph, just these two columns, if I want to say something that is 20 and below age, so then I have to take 20 and all of them. But if I just say below 20, then it is just 18 and 19. So those are the things. Be careful about it. If you look at your table on page number 19, you have your number of days per week and number of students. So if I talk about number of days per week, that is 5, less than 5, it includes all of them, 4, 3, 2, 1, and 0. And so I have to add all of those frequencies, not the percentage. I have to add all of those frequencies to get, and then find out the percentage. So that is another thing to keep in mind. On page 20, it gives you an example of a group frequency, which is with class intervals, because you have men, women, and total. What is really important, here is an example of group frequency again, 60 up to 70. So they are with the class intervals. There is loss of information here because I don't know how many are 61 kgs or how many are 62 kgs, or what is it, that is it all that are 69 kgs, all 13 are 69 kgs. So when we have an intervals, class intervals like this, there is at group frequency like this, there is loss of information. To combat that, we actually have what is called a STEAM stem and leaf display, which helps in removing the loss of information. So I just moved it a little bit so that you guys can see it. So here is my stems, and this is my stem width. So this is basically, that means it is 90, 96. These are the two values shown here. This is 71, this is 76, 76, 77, 78 in this category. So in the interval from 70 to 80, I have 1, 2, 3, 4, 5 values, and I also know the individual values that is there. So there is no loss of information. It tells me the lowest and the highest value. So I know the lowest is 16 and the highest will be 96. It doesn't say the intervals, but it tells me the lowest and the highest. It tells me specific ages within the interval. So 43, 44, 47, 48, because the stem width is 10. It also tells me which one doesn't have any values, gaps inside the intervals. So stem and leaf plot is a really, stem and leaf display is a very good display. The last two things are the histograms and the bar graphs. The histograms and bar graphs are again very good way of representing information. If you look at it, these are both histograms. Do you think they're any different? No, they are the same information, but just their axis is changed. What is the difference between a histogram and a bar graph? If you look at a histogram, your horizontal axis is a quantitative quantity. It is numbers. But in a bar graph, it is actually qualitative. So it is apples, oranges, bananas. So that is one of the biggest difference between a bar graph and a histogram. But both of these are representing data, summarizing the data, providing you with the frequency. So this is your frequencies, and you can label them. Like over here, you'll see it is 5, 10, 15, 20. So I know that how many like apple is 35. I can use this information to actually make a table and do the statistics, find the mean, find the mode, find the mean, median, mode, and do a standard deviation. This is why I explained those things first before I did this. Here I could make, I have not labeled my y-axis, but this could be 10, it could be 20, and then accordingly I will know what is the frequency. Now when you look at the bar graph again, the x-axis is the one that has the number of people. So this was all about the chapter 2. There is more reading, practice, and fun with statistics at this website of readingstats.com. I would strongly recommend you, for at least for chapter 2, take the online interactive quiz, get immediate feedback to understand the concepts better. Do not hesitate to post any questions on the course question discussion board. I will be more than happy to answer your queries. Your quiz is based on this PowerPoint and also on some of those things that is given in your chapter 2. If there are any questions, please do not hesitate. I am here to support you guys be successful in this course during your summer semester. Happy to have you guys in class.